Hello guys and welcome back to this amazing channel. This is Abhinav. Today in this particular video we'll discuss about the solutions of contest Codeforces Round 940. Okay. So we'll discuss the first four problem, which is A, B, C and D of this particular contest, right? So the problem was a bit like a good contest. The problems were also good. These both the problems were based on bit manipulation. This was a good problem of dynamic programming. This was a very easy problem of simple greedy, right? So let's discuss all the problems one by one. Let's first discuss the problem number A, which is Stickogon. Okay, this was a good problem. The problem says that you are given n sticks of length a1, a2 up to an, right? Now you have to find minimum number of regular polygons that you can construct simultaneously using this trick. So the polygon size should be equal, right? And one stick cannot be, I can only be taken once for a polygon side, and that's the basic thing, right? So let's see, obviously, for example, guys, you have some sticks of, let's say you have three sticks of length 4, okay, of 4 centimeter. You have five sticks of, let's say, 6 centimeter. You have two sticks of, let's say, 9 centimeter. You have eight sticks of, let's say, 5 centimeter. You have one stick of 8 centimeter. So what you can do, you have to build polygon, and you have to want like maximum number of polygons that you can create, right? The maximum number of polygon. See guys, what are polygons? Polygons are any type of quadrat, like these shapes which have three or more sides. So a triangle, a square, rectangle, quadrat, these all are polygons, right? So what we will do, because we want maximum number of polygons, means we need to create maximum number of polygon with the given sticks. So what we will do, we will take a polygon that takes less stick, right? So what we will do, we will take a polygon which is triangle. So we will try to make triangles using all these sticks, right? So now triangle need three sticks, means three side. So see, when there are three sticks of 4 centimeter, means one triangle can be built. Five sticks, again one triangle only can be built, because 5 by 3 is one only. Okay, two sticks will be remaining, but you cannot do anything with that because sides of the triangle should also be equal. They are asking. Okay. Now next, uh, uh, next it's like this. So it's basically uh, two sticks of 9 centimeters, zero triangle. You cannot make a triangle with two sticks. With eight sticks, you can make two triangles. 8 by 3 is 2. And with one stick, you cannot make any triangle. So overall, you can make four triangles from these sticks. So what you can simply do is, for each stick, you will first of all segregate using map. Okay, for 4 centimeter, how many sticks are there? Means size wise, you will group up the sticks. Now for each stick with a particular size, you will find how many triangles are possible, right? So if you will see, I did the same thing here. So what I actually did is, I first of all took a map, and for each stick I stored the value in the map. Okay. Now for each stick value, so this IT will contain the weight and the number of sticks. Oh, sorry, that the length and the number of sticks corresponding to that length. Okay. Now for each stick, I divided by 3 and added the answer, just like here. Okay. So it was a little bit of a straightforward question that we discussed. Let's discuss the next problem, guys. Then. Uh, oh, sorry. Yeah. So this is the next problem, which is a bit of a construction. So a bit, right? So bit means it is a bitwise problem, as the name suggests. What the problem says, that the problem basically says that you have two numbers n and k, right? Now what you have to do is, you have to create an array of n numbers, okay, such that their sum is equal to k. So the sum of all the numbers of the array should be equal to k. You can see it's written here. And the number of ones in the binary representation of OR of all the numbers. What is this? This is OR. Means when you will find the OR of all the numbers, the the binary representation of that OR should contain maximum number of ones. So you have to return such an array which satisfies this problem. Okay, if you will see, I made one wrong summation for this also, because I actually I was first thinking the right, but then my mind got diverted. So actually here you have to find a bitwise OR such that it has maximum number of ones. I thought we have to find the value, the array, such that we have the maximum bitwise OR. No, we don't want the maximum value of bitwise OR. We want maximum number of ones in the bitwise OR. For example, if bitwise OR of the number of the of this array is, let's say, 0 1 1 1, or let's say 1 0 1 1, and if the bitwise OR is 1 0 0 0 0 0, so you will see this bitwise OR is greater, but still this is not the right answer. This is the right answer. Why? Because we have to find the maximum number of ones. Maybe the bitwise OR value is smaller, maybe it is less, but the number of ones in that bitwise OR should be greater. Okay, so guys, what we will do, actually, see, we want that the sum of all the numbers of this n should be equal to k, right? Up, see guys, if you want, let's say if you want maximum number of ones, what you will try, you will try to make all the bits of that particular bitwise or equal to 1. You will try to make 1 1 1 1 1. Okay, but you cannot take all the out of that one, because you want the overall sum of the array as k, right? See guys, if you will see, if you will find any power of 2, let's say power of 1, power of 2, power of 3, let's say power of power of 1, power of 2, power of 3, power of 4, power of 5, power of 6, any power you will see of 2, and you will find the bitwise representation of that. It will be like this: 1, then 1 1 0 1 0 0 1 0 0 0, like this it happens. It contains only one, right? Only one bit is set. But if you will subtract 1 from all of that, then you will see what we get. We get a number whose all the bits are 1. And that is what we want. We want a number whose all the bits are 1, means the maximum bits, right? And so this number is basically of type 2 to the power n minus 1. So every number of this type 2 to the power n minus 1 will have ones in all our bits. सारी bit में क्या होगा 1 होगा. And how many bits will be there? There will be n bits. So there will be n ones present in the binary representation of this number. Is it clear? Is it clear? Right. Amazing. तो अब हम क्या करेंगे? What we will do? We will find the maximum such number, the maximum number 2 to the power n minus 1 which is less than equal to k, because we cannot take number more than k, right? So we want the number, see, we want the number 2n minus 1, 2n minus 1 which is less than equal to k. Okay, means we want the number 2 to the power n which is less than equal to k plus 1. Okay, now I have to find this n, right? I have to find this n. So now what I will do, I will take a log both the sides. So I will take log of 2. So we will take n is less than equal to log of 2k plus 1. So if you will find this value of n, this is n, means finally using this n you can also find this value. So this n is nothing but log 2k plus 1. Let's take it as x, because n is another thing which is the number of elements. So if you will see my solution, what I did is I have taken a program where I'm finding the value of log 2, and log 2 of what? Log 2 of actually k plus 1. So if you will see in this function max power of 2, I am passing this k plus 1. I'm passing this k plus 1 here. Now this will find the value of log 2k plus 1 which is x. And finally we will use this x to find the value of this, which is 2 to the power x minus 1. So from here I am returning power of 2 to the power x, and then I am subtracting 1 here. So now this x will contain a number which is in the form of 2 to the power x minus 1, means it has maximum number of ones. Okay, so I will print that number, and if that number is less than k, अगर वो number k से छोटा है, then obviously there will be some left. By k is greater than x, so the remaining sum, because the whole array sum should be k na, so remaining sum k minus x will be printed separately. And then for the other numbers, so we have printed two numbers, x and k minus x. For other numbers we will print simply 0, nothing else. And obviously if n is 1, then answer will be k only, nothing else, right? So let's take an example. For example, if n is 6 and our k is, let's say, 300. Okay, so if you will see, first of all you will find the greatest number which is in the form of 2 to the power x minus 1. So what we did, we will first of all find the value of log base 2k plus 1, right? Basically log base to 301. So if you will actually find the value, let me use calculator to find this value. So अच्छा यार ये कैलकुलेटर में, अच्छा ओके हाँ, तो लॉग बेस 2 कैसे होगा भाई? कैलकुलेटर चलाना सीखना पड़ेगा यार. अच्छा एक काम करते हैं, यहाँ पे निकाल लेते हैं log base 2 calculator. हाँ, so we want the value of log base 2 300. So it is around something 8.294, right? It is 8.294. So if you will see, this will be 8.294. And because we are storing it in a simple LL, it will be actually 8 only. It will be 8. ठीक है. तो अब x की वैल्यू क्या आ गई? X value came 8. So what is the value of 2 to the power x minus 1? So 2 to the power 8 minus 1 is actually 254. तो means एक नंबर होगा 254, which is nothing but 1111111. It has 8 1 bits, right? अब remaining क्या हुआ? Remaining is 46, so another number will be 46, and remaining, because we want 6 numbers, remaining we will have 000. And you will see the sum of this is 300, and it has maximum number of ones, which is this. 8 ones are there. You cannot have more than 8 ones in an array which has some k and bitwise or as this, right? That's the thing. So that's what I'm doing here. That's it. Okay, so this is how I've solved the problem. If you have still any doubt, or if you have a better solution, please do comment it. Okay, or if you have any doubt, you can also join our Telegram channel and ask your doubts, right? Amazing, great. Now the third problem. Third problem was a dynamic programming problem. Maybe some of you will think that okay, how it is a dynamic programming problem, Abhinav, how it's a DP problem, but actually it's a DP problem, guys. Let's discuss how it is. So what actually happens here in this problem is that they are saying you that you are having a chessboard, right? You are having a chessboard, and in that chessboard, whenever you have some rocks, okay? So when you place a rock at a particular row and a column, you cannot place a rock in the same column or the same row, otherwise they will attack to each other. So you have to place rocks such that they should not attack each other. So for example, if this is the grid, this is the grid, right? And let's say you have placed the rock here. Now you cannot place rock in any one of these things, right? That's the first thing. Okay, one more thing, guys. Actually, the size of this grid is n into n, means it is of equal size. So let's create it as equal size. Right, okay. So it is 0 1 2 3 0 1 2 3. Okay, so means for example, if you have placed the rock here, now you cannot place any rock in the same row and the same column. It is not allowed, right? Because they will attack each other. That's the first thing. Now guys, the next thing is that whenever you will place a rock at a particular row and column, for example, you place the rock at index number 1 comma 2 here, okay, and it's a, let's say, a white rock. It's a white rock. So now what computer will do, computer will place a black rock. I am presenting black as blue here. At the black rock at index 2 comma 1, means just mirror reflection of that here. Now let's say if you placed a rock at 1 comma 0 0 comma 1, so it will so okay, one more thing. Now you cannot place it at 1 comma 0 comma 1, because these two are done. Okay, next let's say if you are placing it at 3 comma 3, up you will see that okay, Abhinav, when you will place it at 3 comma 3, now where the computer will place, because reflection of 3 comma 3 is 3 comma 3 only. So in that case, computer will not play, they will skip the turn, and then in the next turn you will place it here. Okay, and you will place it, not computer, right? Like this. So that is the thing that is happening. Now thing that is given to you is that you are already given with the first k moves of yours and corresponding computer. Obviously, when you know your first k moves, so for every move, computer will also make a mirror move, right? That is given to you. Now you have to find that up, like first k moves are done, still if there are some moves left, so in that left moves, how many different combinations or configurations of grid you can take. For example, let's say here if you will see, one move is done, which was here. So basically you kept it at this 1 comma 2, then computer kept it at 2 comma 1. Now after that there are three different moves that you can take, means three different configuration of grid you can get, which are these three, right? अब देखो एक बात समझो. Now understand one thing very carefully, right? Very carefully. See, whenever k moves are done, there will be some rows and some columns that will be occupied, obviously. For example, in that k moves, there will be some rows and there will be some columns that will be definitely occupied, means now you cannot take them in your next move. For example, if k is 3, right, and the 3 moves are like this, let's say 4 comma 8, and okay, let's say n is 6, means the grid size is 6. Let's say first is 2 comma 5, then it's 1 comma 3. Okay, let's say this k is only 2. Okay, okay, wait, let's make this n as 8, and let's say 4 comma 4, right. Up, see one thing very carefully. When you are doing this, means when the 3 moves that are given to you is 2 comma 5, 1 comma 3 and 4 comma 4, see, that means you have occupied the second row and fifth column. And guys, when you will place 2 comma 5, computer will also play 5 comma 2 na, and same for all, right. So when you have placed what we say that, yeah, a rock, right. Yeah, when you play a rook we say it. So when you will play a rook, when you will keep a rook at the second row, means second row is done, and also guys fifth row is also done. Similarly, fifth column is also done, second column is also done. So when 2 comma 5 we took, that means 2 comma 5 row and column both are now fulfilled. Now we cannot choose them later. Similarly, 1 comma 3 is also done, and 4 is also done. So matlab 1 2 3 4 5 is done, because n was 8. Now 6 7 8 are left. ठीक है, and now we have to only choose 6 7 or 8 in our next turns. So हमारे 3 possibility बची हैं, because 1 to 5 are already done. Let's take one more example. For example, our n is 10, okay, and there are let's say 4 moves. Let's say 2 comma 8, 3 comma 3 and 7 comma 5. So what does it mean? It means that if it is 2 comma 8, means 8 comma 2 is also filled. Here it's 3 comma 3 is fine, there is no mirror, and 5 comma 7 is also filled. Basically you can see all the rows at 2 3 5 2 3 5 7 and 8 are filled, and all the columns also of this indexes are filled. So remaining क्या है? Remaining are 1 4 6 9 and 10. These 5 are remaining. Now in the next remaining terms, I have to choose out of these 5 only. These 5 rows and these 5 columns are left. मुझे उनमें से कहीं कुछ चूज करना पड़ेगा. Let's say I opt for 4,6, then I opt for 1,9, then only 10,10 is remaining, and so on, right. अब देखो possibility क्या है. We have to find different number of configurations that are possible. अब देखो guys, first of all what I did in my solution, if you will see here, is that I first of all took a set, okay, and I took this set basically. Okay, I if you see, I took a set, and this set I inserted the row and column, right? So that at the last I can found that how many are left. So which are taken, you can see finally in the fine answer I am passing n minus st size. So st size is something that is already done in the first k moves. उतनी rows और column number हो चुके हैं. That indexes are done. Remaining are total minus done. So these much number of indexes are remaining that we can take in our next moves, right? These are the remaining indexes. And now we are passing this indexes to our function, which is find answer. This is our function. You can see it's a very small function. I will explain you how it is being solved, right? देखो अब कैसे हो रहा है. See guys, for example, you have 5 numbers that are remaining, 5 indexes that are remaining. Just for example, 1 5 6 8 9. These are indexes that are remaining. What you can do? You have two options. Either what you can do is, either you will take one of the index, you will choose one of the index, you will pair it with itself, and for the remaining 4 indexes you will again make a recursion call. Means what I said, let's say you have n remaining indexes, so you will make one pair of any one of the indexes, which is 1 comma 1, any of that, and for remaining n minus 1 you will again make a what API call. API call बोल रहा हूँ, क्या बोल रहा हूँ भाई मैं, recursion call, right? Recursion call. डेवलपमेंट कर करके भाई ऑफिस में डेवलपमेंट, यहाँ पे सीपी एपीआई सीपी सब करके भाई दिमाग खराब हो गया है। सो चलो ये तो हो गया। अब देखो नेक्स्ट व्हाट वी कैन डू, this is one possibility. One possibility is that what you did, you opt for uh, 1 comma 1, right? Matlab you choose any one of that indexes 1 comma 1 and remaining you made a recursion call. Second possibility that you can get it is that out of n you choose two of this, let's say 1 comma 5 or like 5 comma 8, any one of two, and for remaining n minus 2 you will make a recursion call, ठीक है, and you opt two of it, let's say x comma y, ठीक है, and then this will be multiplied. अब देखो ये x comma y भी we can take it as two ways, either x comma y or either y comma x, both are different, because अगर if you will choose x comma y, then at x comma y white rook will be there, and if you will choose y comma x, then at y comma x white rook will be there. So there that are also two different possibilities, but basic understanding is these two possibilities are there. So if you will see, what I did is after passing this n, what I'm doing is, this is my answer, understand this. What is my answer? My answer is, what I'm doing is, first of all I'm making a API call at n minus 1 comma dp is I am adding there just to for the dynamic programming. First, what I said, the first possibility is that among n indexes you will choose one index separate, you will make a chance there, you will take a turn there, and for remaining n minus 1 indexes you will again make a recursion call. That is what I am saying. First possibility is that you have taken one separate and you made recursion call for n minus 1. This is the first possibility, and every time I am taking mod because we have to find answer in mod. Second possibility is that you opt for a particular number, let's say you opt for 1. Now you will pair this one with others. Now see how many pairs are possible. There will be n minus 1 pairs that are possible. N minus 1 pairs possible honge. Am I right? While I said okay, I will take this one. Now I will pair this one with other numbers. So how many other numbers are there? There are n minus 1 other numbers. Means you have n minus 1 choices. What I take n minus 1 and I multiplied it with recursion of n minus 2. Why? Because this is the number we've taken and we've taken one more number from this number. So remaining kitne bache? N minus 2 are left. So what is remaining n minus 2? I made a recursion call and I multiplied this recursion call with n minus 1 because we have n minus 1 possibilities. And also then I multiplied with 2 also. Why with 2? Because this number that we have taken, which is x and y, this can be also written as y comma x. Means there are two different configurations that are possible. So multiplied by, and then we added these both the possibilities. Okay. अब these mods are there. These are like simple mods we know because there is a mod multiplication we are doing. And one more thing, because there can be some that recursion overlapping can be happen. So that is why I'm using a dynamic programming here. Just like if you remember, if we use in Fibonacci number, like similar it is there, similar to Fibonacci number it is there, right? Cool. So this is the problem number C. So I have solved it using this way. If you have any other better solution or if you have any doubt, you can comment that to me in the comment section, or you can also join Telegram channel to ask your doubts. Okay, amazing. Now the very last problem we will discuss of today, which is bit of an inequality. Actually, I'm not able to solve this problem during the contest. So the thing is that this problem was actually good. I was very close to the solution. If you will see the solution, if you will see what I did was very close, right? But I unluckily I was not able to like solve the complete solution within a time. After that, I got the logic. So for now, I will use someone's solution, which is Shadow, to explain it, right? Because the approach is same. That is why I'm explaining. Otherwise, I must have not explained. Cool. तो देखो क्या करेंगे हम लोग यहाँ पर. It is saying that basically you are given with the array a. Okay, now you have to find tuples. Such that, let's say x comma y comma z is tuple, such that the function of x comma y or function of y comma z is greater than function of x comma z. Now what is this function? This function is nothing but, if we are saying function of x comma y, it basically means ax comma ax plus 1 up to ay का XOR. So this function also means XOR of all the numbers from x to y. Ab see guys, see very carefully. Understand this condition first. What this condition is saying. देखो इस कंडीशन में क्या हो रहा है कि if you will see here, it is this basically means that uh, XOR of all the numbers, let's say ax, XOR ax plus 1, XOR ax plus 2 up to ay. That is what is in this. Okay, ये हो गया. अब ये रो क्या है? This is ay XOR ay plus 1 up to XOR az. Okay. अब what is this? This is nothing but ax XOR ax plus 1 up to XOR ay up to XOR az. ठीक है, यही तो है ना. अब देखो गाइस, यहाँ पे एक XOR लग रहा है. If you will compare these both the statements, the only difference in the statement is that this statement has 2 ay and this has only 1 ay. That's it. Means अगर मैं लिखूं इसको तो इसको इससे लिख सकता हूं कि f of x, z XOR ay should be greater than f of x, z, because that's the only difference. इस वाले केस में only one extra ay is there. Everything else is same. So I can write that f of x, z XOR ay should be greater than f of x, z. So basically we want all that ays, means we want all that elements, such that if we make a XOR of that element with a sub array x, z, the value is greater than the original value of that x, z. That's the thing. अब देखो वैल्यू ग्रेटर कब होगी? वैल्यू ग्रेटर तब होगी when the value will be greater when, for example, this ay is 6. This ay 6 is means its bit is 101. That means the largest bit of this number ay is this 1. Now if this 1 is not set in this value f x, z, let's say the value of this f x, z is, for example, it is 9. So if it is 9, you will see that its bit is 1001. Okay, and because it is 1001, this third bit is not set here. So when you will take XOR of this with this, it will set its third bit. It will maybe unset its last bit, that is completely fine, but it will set its third bit, resulting in a greater number than this. This was 9 and this is 12. Means if for a particular value of f x, z, अगर हम उसमें XOR करते हैं with of a number ay which have a largest bit which is not set in this x, z, means that can be a possible approach, right? And you will see, if you will see my code, what I was doing actually. So I actually code in Codeforces compiler. So I was also doing very similar thing. I was taking a prefix sum and all. This is the thing that I was doing, and all of that what I did was little bit different. I was getting actually a very close solution, but there was a little bit doubt, because of which I was not able to solve this question. So let's discuss it from here. देखो हमने यहाँ पे क्या किया हुआ है. First of all, what we did is first of all we took the input of this array ai. Okay, now we will use this array ai as our prefix array. So what we did, we added a 0 in the start. So let's say our array is 6 to 4, which is our first test case also. This is our array A. Now we added a 0 at the beginning of this array. This means insert a 0 at the beginning. Now array became 0, 6, 2, 4, right? अब लोग क्या करेंगे? Now this will find the suffix prefix XOR of this array. So prefix XOR will be XOR till here is 0, XOR till here is 6. अब देखो XOR till here will be 7 and XOR till here will be 5. So this is the XOR. So now A became this. अब देखो अब A यहाँ बन गया, तो now you lose your original array, right? So what he did is, he's a very expert person. He again is told that array in a array f. F क्या हो रहा है? You will see fi is equal to ai XOR ai minus 1. So basically this will reverse your prefix XOR. So now f will be f0 will be 0 only. This will be the XOR of this and its previous. This will be the XOR of this and its previous, which will be 2 actually. and this will be the XOR of this and its previous, which will be actually uh oh wait, yeah, AI is or AI minus 1 na, that is what I'm saying. It is AI is or AI minus 1. So whatever we did, it will be 6 or 06. This will be 7. Initially it was 6 to 4, right? तो 7 कैसे हो गया? ओके सॉरी, वही मैंने कहा, मैंने एक्चुअली में गलत निकाला है ए. तो इनिशियली ए वाज 0624, राइट? So it will be 06, then 6 and 2 will be actually 4, and then finally 4 and 4 will be 0. So that will be the case, right? Now this will be 0 comma 6 comma 6 and 4 will be 2, and 0 4 will be 4, right? So finally इस f में वापस से आपकी array store हो जाएगी जो original array. So now this a is actually the prefix XOR array and this is the original array, right? Amazing. अब देखो what we did. So this is the आगे and पीछे vector that it's taken. It is basically a prefix and suffix vector only. So what is आगे and what is पीछे? So आगे means for a particular index and for a particular bit, how many numbers are present after it, means कितने नंबर उसके आगे present हैं जिसकी वो particular bit on है. How many numbers are present after that index whose that particular bit is on. So if you will see, total we have taken 32 bits, right? So what we will do, for all the numbers from 1 to n, for all the numbers of 1 to n, we will see कि for the number ai and for the bit j, क्या इस ai number की ये j bit on है? So what does it mean? It is left shift 1 j times. So this will be basically nothing but 2 to the power j. And when you will do the AND of 2 to the power j with ai, that means if in ai this jth bit is set, it will give true. This means that in this number ai, jth bit is true. That means we found a number whose jth bit is true. So we'll actually increase the value of aage j plus plus. That means basically here what I am doing, here for all the numbers from 1 to n, you will store that for all the numbers and for each bit how many times that bit is set. कि जो jth bit है ये कितनी बार set है in all the numbers, right? Now what we did, now I will simply take a loop from 1 to n and for all the bits. Now I will start from the backward. पीछे से आएंगे. अब देखो पीछे से क्यों आएंगे? Because as I said you, when we checked here our previous case, you will see we checked that which is the maximum bit of 1. तो जो 6 की maximum bit है वो 1 थी. So ये 1 जो है ये इस रेंज में सेट नहीं होनी चाहिए. So if there is a subarray in which that 1 is not set, so that we can add that ay and that we can set that 1, right? So first of all, for this number fi, we are first considering that हम इस fi को y माने. If we will take this fi as our y element, which is in the middle, so how many such these tuples are possible? So first of all, we'll find the maximum bit of this fi, right? तो maximum bit क्या है? So अच्छा, one more thing it is happening here. Maximum bit हम लोग different में find कर रहे हैं. So we are starting from the backward. We are starting from the back, from bit number m minus 1 to 0 we are going, okay? अब देखो, first of all we are taking this j. अब देखो, if this j is present in fi, means this j is the maximum bit that is present in fi. मतलब क्या है, हमने क्या कह रहा, हमने maximum bit find कर ली. Whenever we got the maximum bit, just like for this 6, its maximum bit was this 2 की power 2. 2 की power 2. Second bit is the maximum, means for j2 it is maximum. So whenever we get a value of j such that it is present in fi, you what you will do, you will do this. अब देखो ये क्या है, अब देखो ये क्या है, understand very carefully. What does this आगे j presents? आगे j means that for that number I, how many numbers are present after it such that, or basically number of j bits which are set after this index. So इस index के आगे how many j bits are set. Now पीछे means that how many j bits are set before this number. That's basically it means that how many j bits are set after this number and how many j bits are set before this number. Means how many numbers are there that have the jth bit as set. That is what this आगे j and पीछे j will means. अच्छा, if you will see, आगे जो तो आपको पता है कि ओके इस नंबर के आगे कितनी सेट है, वो हमने निकाल लिया ऊपर. व्हाट इज पीछे जे? So you will see as we are going from I to from 1 to n, what we are doing after every iteration we are actually decreasing आगे जे, because when we move forward, मान लो इस नंबर में कोई j8 bit set है, that means अब वो उसके पीछे चला गया नंबर, now that number went backward, so for that bit will increase its पीछे वाला vector and its आगे वाला vector will reduce, right? That's the thing. So now what we will do, first in my answer I will add आगे j into पीछे j means number of numbers that have the jth bit and which are after that, and numbers that have their jth bit set which are before that, right? That will multiply. I will tell you why. And next is this thing. अब देखो हम कर क्या रहे हैं. See, we have to actually take a sub array from x to z in which y will be present in between, such that that sub array XOR value should not have this jth bit s set. ठीक है, तो हम क्या करें, हमें पता है कि मान लो इस y के पहले there are x numbers which have their jth bit set, and after this y there are y numbers which have their jth bit set, that we know using आगे j and पीछे j. We know how many numbers are there before y which have their jth bit set, how many numbers are after y which have their jth bit set. Now see very carefully what I will do. I want even number of such numbers. Why even number of such numbers? Oh sorry, I want odd number of such numbers. So I will take some numbers from the backers. Let's say I took a numbers from the before of y, some numbers from the after of y, let's say b, and one number is here also. This y is also there, na? So over we have a plus b plus 1 numbers that have their jth bit set. And see guys, if this is an even number, that means if jth bit is set even times, so in the XOR value this jth bit will become not set, and that is what I want. I don't want my jth bit to be set so that बाद में जब मैं वो ai डालूं उसमें तो वो उसको set कर दे और नंबर को बढ़ा दे. Initially I don't want my ah bit to be set. That means I want this value should be even and I want a plus b to be odd. What I will do, I will take some numbers from the backward of it and some numbers from the forward of it, such that their sum is a odd number. That means there should be odd numbers of set bits of j, right? तो कितने ऐसे possible combination होंगे? There will be this much number of possible combinations, that will be multiplication of this, right? अब ये क्या बोल, this is saying how many numbers are there which so this says how many numbers are there which have the jth bit as set. This will say how many numbers are there which have jth bit not set, because the number which don't have jth bit set, that is also fine. वो भी ले सकते हैं ना जिनमें jth bit set नहीं है. Numbers in which jth bit is not set, that is also fine, because obviously अगर हमने एक array of number निकाल लिया in which jth bit is not set, we can set it ना. So how many such numbers are there? See, first of all, n minus I plus 1 are the numbers which are present after ith index. उनमें से आगे j वाला number whose jth bit was set. So if you will find the difference, that is the number whose jth bit is not set. Similarly, till the ith index, like before the ith index, there are I numbers, and in which पीछे j was the number whose jth bit was set. So I minus पीछे j do not have the jth bit set. So I got that. And now I multiplied that also. So this basically represent the numbers after I which has jth bit set into numbers before I which has jth bit set. This is numbers after I which does not have jth bit set. This is number before j which does not have jth bit set. And then the multiplication, because we want all the possible combinations of x and y, x and z, right? So guys, this was actually a very complex code. Even I was writing a more complex code, but yeah, this was also very close. If you will see here also, I'm finding this multiplication of even and odd and all of that. There was a little mistake that I was doing, but no worries, this was actually a very difficult problem. This only you will understand if you have a good understanding, you know, of this concept, which is just very similar to or very close to dp. Okay, it is very similar to dp and bit, so it was actually a very hard problem, right? Cool guys, so I hope that you have got a good understanding of all the 4 problems. If you still have any doubt, please feel free to comment down your doubt or join our Telegram channel. Thank you.